Okay, this is active filter design lecture 5. In the last class, we were trying to find the roots of the Chebyshev approximation. So in other words, to summarize, we found that h of s times h of minus s evaluated at s is equal to j omega, which also happens to be the magnitude squared response of the approximation, turns out to be of the form 1 by 1 plus epsilon square Cn square of omega, where Cn of omega is given by cos of n cos inverse omega for 0 less than omega less than or equal to 1, and is cos hyperbolic of n cos hyperbolic inverse of omega for 1 correct. So this is nothing but 1 over d of s times d of minus s evaluated at s is equal to j omega, which therefore means that to find the denominator polynomial itself d of s, all we need to do is take a look at the denominator, replace omega by s by j. So this is now a polynomial of order what? This is a polynomial of order 2n. N of these roots will be in the left half s plane, while n will be in the right half s plane. We associate the roots of d of s with those in the left half plane and discard the rest as they are presumably belong to d of minus s. So let's go through the mechanics. This basically means that Cn of s by j is plus minus j by epsilon, okay, and Cn is nothing but cos of n cos inverse of s by j is plus minus j by epsilon. And I mean, we see that cos of some argument is a complex number. Therefore, in the general case, this argument must also be complex. You denote that by u plus jv. Okay. So you have cos of u plus jv is plus minus j by epsilon, and this means that cos u cos of jv, which happens to be cos hyperbolic v, minus sin u sin of jv, which happens to be j sin hyperbolic v, is plus minus j by epsilon. Please recall that u and v by definition must be real. Now, equating real and imaginary parts on both sides of this equation, we see that this is only possible if cos u is 0, which means that u must be of the form 2m plus 1 times pi by 2, where m is a integer. All right. So, and minus sin u sin hyperbolic v is plus minus j by epsilon, sorry 1 by epsilon, which means if cos u is 0, sin u must be plus minus 1, which means that v is plus minus sin hyperbolic inverse 1 by epsilon. Correct? Now, u plus jv, recall, is nothing but n cos inverse s by j. You understand? Cos of n cos inverse s by j is plus minus j by epsilon naught, j by epsilon, which basically means that u plus jv is nothing but n cos inverse s by j. We are trying to find the roots. In other words, we are trying to get at the s's which will satisfy that equation. Correct? So this means what? Cos of, which means s by j, is nothing but cos of u by n plus jv by n. Does this make sense? Which means s by j is cos u by n cos hyperbolic v by n minus sin u by n j sin hyperbolic v by n. Correct? Is this clear? Which means the roots are of the form, this must be plus minus, right? Sorry, it's minus, okay. So we've already figured out what the u's and v's are, so it's just replace. So this is this must be minus sin u by n sin hyperbolic v by n. And what is sin hyperbolic, what is v? Please note that v is nothing but plus minus sin hyperbolic inverse of 1 by epsilon. So this must be plus minus 1 by n sin hyperbolic inverse 1 by epsilon. Correct? Plus j cos u by n cos hyperbolic 1 by n sin hyperbolic inverse 1 by epsilon. Cos, the plus minus on the sin hyperbolic inverse doesn't make any difference because the cos hyperbolic is an even function of the argument, so it doesn't matter. Okay, and what values does u take on? U must be 2m plus 1 into pi by 2, where m goes from 0, 1, 2, 3, blah blah. Okay, so please note that this is quite unusual, right? If you generally have an nth degree polynomial, it is not very normal to have, unless the equation is trivial, right? You usually do not have clean closed form solutions for the roots. Okay, because the special nature of the polynomial, it is possible. I mean, in general, what we would have to do is we find the roots numerically, correct? But in the special case, because of the special nature of these polynomials, the roots can be computed analytically. Okay, and the roots are given by this expression. Okay. So given the order of the filter, this is known, n is known. Given the ripple, epsilon is known. So the rest of it is just, you just plug the various values of u and compute the roots. And what must you find? You will find if a particular root is complex, then you will find its mirror image both about the real axis as well as the imaginary axis, which basically is what you are looking for, because if you had a complex root, then because of real coefficients you must have a complex conjugate root, and because of this d of s into d of minus s, right, you will also have mirror symmetry about the imaginary axis. Okay, all right. And so if I denote the roots by this sigma naught plus j omega naught, okay, it's nothing but plus minus sin u by n sin hyperbolic 1 by n sin hyperbolic inverse of 1 by this thing plus j cos u by n cos hyperbolic of 1 by n sin hyperbolic inverse of 1 by epsilon. A couple of minor points that I'd like to point out. Okay. What is just by observation, sigma naught is obviously the real part of this of the root, and omega naught is the imaginary part of the root. A simple observation that I'd like to bring to your attention is to notice the following fact: sigma naught divided by sin hyperbolic 1 by n sin hyperbolic inverse 1 by epsilon, this is the whole square, plus omega naught square divided by cos hyperbolic 1 by n sin hyperbolic inverse 1 by epsilon, the whole square is equal to 1. It's sin square u by n plus cos square u by n is 1. Okay. So this is of the form x square by a square plus y square by b square is 1. So what is the, so the question is, any root of the Chebyshev denominator satisfies this equation, which means what is the locus of the roots? It is an ellipse. Okay. So this is in comparison to a Butterworth filter where all the roots lie on a circle, whereas that of a Chebyshev filter lies on an ellipse. Does that make sense? So the observation is that the roots lie on an ellipse. Okay. All right. And which is larger, sin hyperbolic 1 by n blah blah or cos hyperbolic 1 by n blah blah? Cos hyperbolic. Okay. So will this be a long skinny ellipse or a short fat ellipse? I mean, it could be anything, but what will it be? It will be a, I mean, the question I was asking was, will the ellipse look like this or will it look like this? I mean, both of these are not ellipses, but the second one, right? And that's because cos hyperbolic 1 by n blah blah is always, I mean, both sin hyperbolic and cos hyperbolic have the same argument, and for the same argument you know that cos hyperbolic is always larger than the sin hyperbolic. Does it make sense? Okay. You understand? Okay. So let me also, since we are at it, let's compare the stuff with a Butterworth example. In a Butterworth example, what did we say? 1 plus omega square whole to the n is 0 for the Butterworth. Which means that this is j square, and I will just call this, just to put it in perspective, s by j whole to the 2n is minus 1, which is also the same as j square, or e to the 2m plus 1 into pi. Correct? This is the equation we had for the Butterworth. Now, all that this means is that s by j is nothing but e to the 2m plus 1 pi by 2n, which means that the sigma naught plus j omega naught, the root of the Butterworth, is given by cos the real part will be sine. This is cos plus j sine. So this will be sigma naught will be minus sine 2m plus 1 into pi by 2n, right, plus j cos 2m plus 1 into pi by. So Butterworth poles lie on a circle, Chebyshev poles lie on an ellipse. So if you compare the poles, if you draw a picture, if this is a circle, the Butterworth poles, for example, could be the d of s into d of minus s, the poles on a circle and denoted by the red crosses. That corresponds to Butterworth or Chebyshev now? Butterworth. Okay. Now if I want to have what order Butterworth is this? The third order Butterworth. Okay. Now if I wanted to have if I had a Chebyshev filter, third order Chebyshev filter, how do you think and if I had tuned its band edge to be roughly the same as that, tuned its 3 dB bandwidth to be roughly the same as that of the Butterworth, where do you think the poles would lie? So it will be an ellipse, the poles will all lie please note that the U's are the same, Butterworth or Chebyshev, correct? So the poles must lie on these axial lines, correct? It's only the distance which will change, right? So it will turn out that, for example, if you do this, a possible candidate is it will be, and it will lie on the, one pole must lie on the negative real axis. So it's one possibility is this is a bad ellipse, but as an illustration, for example, something like this. Okay, and you can see that that's the ellipse. You understand? And this also gives us intuition about the Butterworth being thought of or interpreted as a special case of the Chebyshev. Okay, now we are all engineers, right? The math part has all been derived by the mathematician, but it shouldn't take too much to understand that the Butterworth is a special case of the Chebyshev. How will I make the Butterworth look, Chebyshev look like a Butterworth? Pardon? By just setting, I have a knob where epsilon, if I turn epsilon down, what happens to the ripple? If I reduce epsilon, the ripple decreases. So, right? So, in the limiting case, when I make epsilon tend to 0, then this will be the upper and lower ends of the pass band will merge, therefore becoming as flat as possible. Correct? Okay. So, I have in your tutorial there is one way of proving it. Okay. This equation gives you another way of proving it, and what is that? As epsilon becomes very small, what happens to sin? What happens to 1 by epsilon? 1 by epsilon becomes extremely large. If 1 by epsilon becomes extremely large, that basically means that this argument and this argument becomes I mean, the arguments are equal always. No. But what happens to 1 by n if 1 by epsilon tends to a large number? What can you comment about 1 by n sine hyperbolic inverse of 1 by epsilon? It also is a large number. Now, if you have a large number as the argument, is there a big difference between sine hyperbolic and cos hyperbolic? No. Why? Cos hyperbolic is e to the x plus e to the minus x by 2, whereas sine hyperbolic is e to the x minus e to the minus x by 2. So, if x becomes large, e to the minus x is so small in comparison with e to the x that whether you subtract e to the x or add e to the, whether you subtract e to the minus x or add e to the minus x, it doesn't make any difference, right? So, when the ripple tends to 0, you would see that, you would expect to see that this will tend to behave like a Butterworth filter, and that's indeed brought out by the maths. If epsilon becomes very small, the sine hyperbolic and the cos hyperbolic tend to become equal, right? So, if you take an ellipse and make the x by a the whole square, a general ellipse is x by a the whole square plus y by b the whole square is equal to 1. So, when does the ellipse become a circle? When a equal to b, and as we expect, as epsilon tends to 0, we see that the a is tending to b, therefore, reinforcing our intuition that if you reduce or squish epsilon down to 0, you would expect Butterworth kind of behavior. Does that make sense? And another thing which is also brought out by the math is that as you switch down the ripple, can you comment on the 3 dB bandwidth of the Chebyshev? It must increase. So, that's also brought out here. As epsilon becomes smaller and smaller, right, we see not only do the sine hyperbolic and cos hyperbolic tend to become equal, both of them are increasing in absolute value, correct? And therefore, it does make sense, because as you reduce the ripple, you would expect that the slope of the transition band becomes sharper more. The transition band will be much wider, which means that the 3 dB bandwidth will increase, which is basically also being brought out by the math. You understand? Okay, so that finishes the discussion on Chebyshev filters. I believe I also added a remark that for an even order Chebyshev filter, what is the DC gain? So what is the order of this filter? This is a fourth order. So please bear this in mind. An even order Chebyshev filter has a minimum of transmission at omega equal to 0. Okay. Whereas an odd order Chebyshev filter will have a maximum at omega equal to 0. Okay. Does it make sense? And I have already discussed how to find the frequencies of maxima and minima of transmission. It's quite straightforward. All that you have to do is equate cos of n cos inverse omega to either 0 or 1. Okay. If cos of n cos inverse omega is 0, then this is the minimum or maximum of transmission. It is a maximum of transmission, whereas if it is 1, it is a minimum of transmission. Yeah, plus minus 1, right? You would equate the magnitude to 1. Is this clear? Okay. So, yes, so far we have seen all pole filters, and we have considered two popular magnitude approximations, one being the Butterworth and one being the Chebyshev, intuitively we can expect that we are tolerating a lot more ripple in the pass band with the Chebyshev approximation. So, for a given brick wall spec, you would expect the Chebyshev filter to have a sharper roll off. In other words, for a given brick wall spec, you would expect a lower order for the Chebyshev when compared to a Butterworth. So, how will you figure out the order in the Chebyshev? So, let us say you want the DC gain to be 1. At omega 1, you want the gain to be at least G1. At omega 2, you want the gain to be at most G2, correct? I mean, that's how you specify a filter. Okay. Now, what is the smartest way of choosing epsilon now for a Chebyshev? We know that you can do best with the order when you allow as much ripple as possible. Clearly, you can make use of the entire width of the band. So, 1 to G1 for the ripple. So, therefore, you choose G1, you choose epsilon such that G1 is 1 by 1 plus epsilon square. Is this clear? Okay. Once you do that, to find the order, use the standard 1 plus epsilon square Cn square of omega 1 by omega x, right? Sorry, if I choose that ripple, that will be, sorry, omega 2 by omega x, okay, to be equal to, should be smaller than 1 by, sorry, G2 square. Correct? So, and what value of omega 2 will you use, and what value of Cn will you use? I mean, omega 2 is in the stop band, presumably G2 is much smaller than 1, which basically means that the expression you must use for this must be the cos hyperbolic of n cos hyperbolic inverse of omega 2 by omega x whole square must be less than or equal to. Is this clear? And this is exactly the same manner as we proceeded in the Butterworth example. Does this make sense? All right. So, yes. So, how to get mod h of j omega the whole square? That we figured out, right? In a way as to approximate the ideal brick wall spec to in some manner as as we seem fit. The next thing is, given mod h of j omega whole square, from this to h of s we have also figured out. Okay. And we have done this only for the all pole family of transformers. Okay. Now, somebody was asking yesterday, so far we never seem to have bothered about the stop band at all, right? So, why do you always look at only the pass band? And sure enough, you can also do the stop band. I'll take one again popular example. So instead of going on specifying the stop band, what we say is the following. We are in the Chebyshev examples, what we saw was that the in the pass band the response must hover around 1, and in the stop band we just take whatever we get. Okay, we can ask the the reverse question, which is, what is the reverse question, you might ask? In the stop band, I want this much rejection, which is equivalent to saying that my response shouldn't exceed some maximum, okay? And in the pass band, I take whatever I get. You understand? So, I mean, apart from the, what do you call, the rather harmless requirement that the DC gain must be 1. I need to normalize anyway. So, I will say that my DC gain must be 1. In the pass band, beyond that, I have no particular wish list. In the stop band, I want to make sure that the attenuation or the gain never exceeds some quantity, and in line with the weird Chebyshev value of 1 by 1 plus square root 1 plus epsilon square, here you have a somewhat equally weird looking quantity, which is epsilon by square root 1 plus epsilon square. In a couple of minutes, it will become immediately apparent why this weird value is chosen, given that you bought the other one. Okay. And also analogously, what will happen is that instead of calling, we don't really care about the pass band now. So, this frequency omega equal to 1 becomes the, what do you call it? In the Chebyshev case, we call that part where the stuff leaves the pass band as the pass band edge. Here, this is the frequency at which the response enters the stop band. This is called the stop band edge. No, we are not. No. So again, the procedure is the same. What would we want to do? We want to find a polynomial of the form 1 plus f of omega square, correct, such that it behaves in some fashion as shown here. And you can see that at these frequencies, the response actually goes to 0. So, can you comment on whether this can be done with only an all pole filter? No. Right, there are finite zeros, and where are the finite zeros? In the S plane, where are the finite zeros? They are on the j omega axis, correct? The frequency response is after all evaluation of h of s as you go along the j omega axis, isn't it? If the frequency response shows finite frequencies where the response is actually 0, it means that there are zeros on the j omega axis, which means that this approximation cannot be an all pole filter, correct? So, there must be a numerator, alright, which means that f of omega square cannot be a polynomial, it must be a ratio of polynomials. Okay, all right. So there are several ways in which you can approach this problem. One is to kind of start doing going through an exercise that we did for the Chebyshev example, right? Another thing is to say, hey, we did a lot of hard work figuring out the Chebyshev. Yes, no? Yes. Or I did all the hard work. Okay. So now it must be, it seems, at least it looks kind of similar, right? It seems as if I should be able to not go through that whole rigmarole again. Maybe looking at that, and trying to notice the similarity between that response and this response. Please note, pass band there has become similar to the stop band, is similar to the stop band here, correct? Looking at the similarities between the two, perhaps I would be able to reuse all the math that I did there, right, without going to have to go through it all over again. Okay, all right. So now that I have motivated the line of action, let's see what we can do about it. So this is the magnitude squared. This is the magnitude. I will copy and paste. Okay. So now what is the squared magnitude? This must become epsilon square. This must become epsilon square by 1 plus epsilon square. Is that clear? So now this must be 1 by 1 plus f of omega square. Correct? So how does f of omega square look like? What does f of omega square look like? Or rather, before we jump to f of omega square, what does 1 plus f of omega square look like? It will start with 1, right? At the band edge, what will happen to it? It will increase to at, this will go to 1 plus 1 by epsilon square, and then at okay, at this frequency, at the first 0 of the response, what will happen to f of omega square? Must go to infinity. Okay, at the maximum, what will happen? The first maximum, what must happen? It will come back to 1 plus 1 by epsilon square, then go to infinity, again come back to this thing, and then eventually as omega tends to infinity, this will also tend to infinity. Is that clear? So does it make sense? Okay. Now, if 1 plus f of omega square looks like this, what must f of omega square look like? You subtract 1, so this goes from this must be 1 by epsilon square, and this is f of omega square, right? And just like in the Chebyshev, where we decided to get rid of the epsilon, we denote this by 1 by epsilon square times f1 of omega square, correct? And how does f1 of omega square look like? I copy and paste. This becomes 1. Okay. So, in other words, mod h of j omega square can therefore be written as 1 by 1 plus 1 by epsilon square f1 of omega square. Does it make sense? Okay. All right. Now the question is, how do we relate this to stuff we already know? Okay. In the Chebyshev approximation, what did we have? In the passband, this f of omega, f1 of omega square would ripple between 0 and 1. Here, stuff is rippling between 1 and infinity. However, it is not rippling between 1 and infinity in the passband. It is rippling between 1 and infinity in the stop band. Okay. So we will handle this as a two-stage process. One, we will make it ripple between 0 and 1. Okay. And then move that to the rippling between the passband to the stop band, vice versa. Okay. So now, if this is f, how do you make something which goes from 1 to infinity go to something which goes between 0 and 1? 1 by that. So if this is f1 of omega square, 1 by f1 of omega square will look like what? At 0, what will it be? Infinity. Okay. What will it be at 1? 1. Okay. Then what will it be here? Okay. And then here it will be a maximum. Be 0 here again, maximum, go to 0, and you understand? Okay. Now we have something which resembles the Chebyshev even more. Correct? So now the rippling is between 0 and 1. However, it is happening in the interval 1 to infinity rather than 0 to 1. So what do we do? Invert the argument. So this becomes, if I do 1 by f1 of 1 by omega square, it will become, if I transform omega to 1 by omega, what happened earlier at omega equal to infinity will now happen at omega equal to 0, right? What happened at omega equal to 1 will remain at omega equal to 1. So how will this look like? This will look like and what happened at 0 will look like what used to happen at 0 will look like what now happens at infinity. Is that clear? Okay. And what is this maxima here? 1. Okay. Now this looks very familiar. And what is this? So in other words, 1 by f1 of 1 by omega square is, what might that n be in this particular example? 5. Correct? So C5 of, in general, Cn of omega the whole square. Correct? Which means, what is f1 of omega square? Please note, we are not interested in 1 by f1 of 1 by omega square. We want to find f1 of omega square. So if 1 by f1 of 1 by omega square is this, what must f1 of omega square be? 1 by Cn of 1 by omega whole square. Does it make sense? Okay. Now, therefore, mod h of j omega whole square is 1 by 1 plus 1 by epsilon square times f1 of omega square, which is Cn square of 1 by omega the whole square. Is this clear? Which basically means that epsilon square Cn square of 1 by omega the whole square divided by 1 plus epsilon square Cn square of 1 by omega. Sorry, I'm sorry. It's yes, it's a function. I'm sorry. Cn of 1 by omega the whole square. Okay. Actually, I think I will just denote this by Cn square of 1 by omega. Okay. In which case, this simply becomes Cn square of 1 by omega. This, so the approximation becomes epsilon square Cn square of 1 by omega divided by 1 plus epsilon square Cn square of 1 by omega. Okay. Now, to how do we find the roots of the equation? So, this clearly is the ratio of polynomials in S, okay, in 1 by S actually. But what is the degree of the numerator? It is 1 by, the highest degree will be 1 by S whole to the power 2n. The denominator will also be this whole 2n, right. So, you can go and do the math. I mean, you have now, as we expected, you must have a numerator polynomial and a denominator polynomial. They are all polynomials in 1 by S, but you can multiply by S to the power 2n and get polynomials in S. And again, if we already found the poles of an nth order Chebyshev filter, then finding the poles of this is actually quite straightforward, because for a Chebyshev, please recall that we were solving the equation 1 plus epsilon square Cn square of S by j is 0, correct. Now, what we have is 1 plus epsilon square Cn square of j by S is equal to 0. Right. So, earlier if S by j was given as what was this, some sigma naught plus j omega naught. Now, j by S is sigma naught plus j omega naught. Correct? Only the argument has changed from S by j to j by S. Okay. So, which you can show is equivalent to replacing the Chebyshev denominator. Instead of S, you use 1 by S. Okay. All right. So, you can say the Chebyshev denominator dc of S, you just do dc of 1 by S. Okay. And to find the numerator, all right, now question, we found that all the roots of the Chebyshev lie on an ellipse. Can you comment on how the roots of these guys will lie? Do they also lie on an ellipse? Yes? Why?
Just the inverse of it.
So what?
Ellipse has omega naught. The sigma is j omega naught. Let me sigma is minus j omega naught divided. Sigma minus j omega naught plus square root.
Yeah, so what? No, the question is, please answer my question, which is, in the Chebyshev example, we found that the poles will lie, the locus of the poles is an ellipse, correct? The question now is, are the poles of this approximation also, do they also lie on an ellipse? If earlier S was a root, now 1 by S is a root. So, that doesn't mean they lie on an ellipse.
So if you have one root and
Symmetry about real and imaginary axis only means that there is these guys, okay? But that's not what I'm asking you. If you have a whole bunch of roots, right? In the Chebyshev example, these guys will lie on an ellipse, right? Now what is happening? The roots are 1 by whatever you had before, okay? So what happens? The magnitude, becomes 1 by whatever, and the phase becomes negative, but then there's a corresponding mirror here, so that will come. The question is, if you had a shape, so in other words, the locus, which was something, is getting transformed by 1 by S or 1 by Z, correct? Okay, so a transformation 1 by Z in the complex plane keeps what as what? Okay, it keeps 1 as 1. Yes, that's true. Yes, yes, but in general, poles will become zeros, zeros become poles, 5 will go to 1/5, 6 will become 1/6. Yes, it's all true, but
like that r e to the power j theta will become
1 by r e to the I minus j theta. Yes, 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 but in general, all straight lines and circles will go to straight lines and circles. You understand? This is a special case of the linear fractional transformation Az plus b divided by Cz plus d, right? Okay. So, where A is 0, B is 1, C is 1 and D is 0. Okay. Such a transformation is called a linear fractional transformation in complex analysis, right? And the special elegant property of this is all straight lines and circles in the original plane will transform into straight lines and circles in the transformed plane. In fact, even the straight lines is redundant because the straight line is in fact a special case of a circle with infinite radius, correct? So, all circles transform to circles, okay, but that does not mean that all ellipses transform to ellipses, okay. So, though it is tempting to say that these roots will also lie on an ellipse, it is not quite correct. You understand? It is a trivial point, a fine point rather, but it is easy to tempting to jump to that conclusion. They in fact do not lie on an ellipse. Okay, so there must be a name for this. Okay, so we seem to be taking inverse 1 by, and then inverted the y axis, we inverted the x axis. So it is only fair that we call this the inverse Chebyshev approximation.
So in that case, what will be the shape of the pool?
You find the ellipse and then do 1 by s. So you will get something which is fat and skinny and short, right? That's about all you can say about the shape. You understand? You take something which was like this and do 1 by x, you will get something which looks somewhat like this. Okay, but this is not an ellipse. That's all. Okay, this is called the inverse Chebyshev approximation. How will you find the numerator? You know
Cn of 1 million of terminated.
Yeah, so you know frequencies at which Cn goes to 0, they must be the zeros of the polynomial, right? So you can find the roots. So I will conclude inverse Chebyshev with an example tomorrow. I will stop.